Welcome, everybody. I'm Linda Coffey. I am a livestock specialist with NCAT, and I'm super happy to be here tonight and have you here because we are going to have a really fun class with 3 of my NCAT coworkers speaking, and I hope that you really enjoy it and benefit from it. Next, Carlos. Carlos Vences, my coworker, is the magic man behind the scenes. He's going to be running the slides for us and doing polls. I'd encourage you all to introduce yourself in the chat so that we get a better sense of who is here. Tonight is the foundational piece for this entire series, and I'm very excited. We have Nina Prater talking about soil health principles, and then Justin Morris will teach us about grazing management. Lee Reinhardt will talk about some of the principles that illustrate that our management really matters about what's happening on our farm. Here at NCAT, we like to do an interactive presentation, and that's a lot harder with virtual. That's where I really encourage you to use the chat, put any questions that you want. We will also have Q&A time at the end of the hour when we're through with the presentations, but please interact. A lot of my coworkers are here and are going to be answering questions as we go. Linda Poole, Margot Hale, Justin Morris, everybody wants to give you the information that you need, so please do reach out. We're going to have a few polls in here so that we can have a better sense of you and where you're at with your education and with your journey. Those will be short and they won't take very long. So the overall plan this week, next week, the next week, by the end of this course, you're going to have the information you need to be a good steward of your land. And when we are a good steward, we have a farm that is healthy and productive and profitable and beautiful. And so I'm very excited to present to you the NCAT team through this series, and we're so happy that you came to join us. Next. Nina Prater is a soil specialist. She's based in our Arkansas office, and I will let her tell more about herself and turn it over to you, Nina. Thank you.
All right. Thank you, Linda. Is my sound okay? Okay. I am so excited to be here with you all tonight to talk about soil health for a livestock production system. Next slide. I am based out of our Fayetteville, Arkansas office with Linda, and I'm a soil specialist here. So this is really my passion. I could talk about it all day, but I only have 20 minutes, so I'm going to be going pretty quickly. And I also have a farm down in Cedarville, Arkansas called Cedar Creek Farm. It's my husband's family farm, and we have a small cow-calf operation. And I had to take a goat selfie with one of our baby goats. We have a meat goat operation as well, and we use adaptive management grazing, or whatever you want to call it. We move our cows a lot to build up the soil on our farm. So it's something I'm passionate about pursuing in the field and helping others understand how to do that themselves. Next. So just to talk about, just to get us all on the same page about what is soil health. Previously, people talked about soil quality or soil type, but those things don't encapsulate the fact that soil is a living thing. And so I use the term soil health because soil can be on a spectrum of healthy to unhealthy. Next, Carlos. So the definition I like to use is soil is healthy if it functions as a vibrant living ecosystem, sustaining plants, animals, and humans. A lot of times people think of soil as just mineral particles, but there is a whole lot of life underneath the soil that goes on. You can see that picture of the soil food web. It's got all different kinds of critters that live under there, from the microscopic bacteria and fungi and things like that we can't see, all the way up to vertebrates like moles and birds that depend on the insects in the soil. So to have healthy soil, you have to have a robust soil food web going on in there, and that biological activity is what builds soil health. In the picture of the two hands holding two different soils, those are from the same soil type, but you'll see one basically looks like a rock. It's so compacted and it doesn't have any structure. And the other one looks loose and crumbly and it's got roots sticking out. And that has a lot of space, pore space and things like that, that biological activity can happen in and water can infiltrate. So that's what we're talking about when we're talking about a healthy soil, is one that looks like nicely structured versus one that that's really been depleted and degraded. Next. So soils, it's really important to keep in mind that all the soils that we're working with here have been created by natural ecosystems. So I like to quote Wordsworth as a former English major, let nature be your teacher. When we're looking at how to manage soils, it's good to look at how they were built in the first place, in the natural processes that did that, so that we can mimic those in our agricultural systems. Next. So people have come up with 5 soil health principles that are based around these natural processes, and it's really how to adapt those processes to an agricultural system. What principles can we follow in order to make sure we're not just not degrading our soils, but also improving them as the years pass? So they are, I'll go over these each one individually, but they're minimize disturbance, maximize biodiversity, keep the soil covered, keep living roots in the ground as much of the year as possible, and include animals. And that's a perfect soil health principle for a livestock workshop. So I know you'll all enjoy that one. But what's the sort of uniting factor here among all of these soil health principles is that they all use the plants to feed the soil. So, a lot of times we think about the soil feeding the plant, providing all the nutrients that the plants need, but the plants actually are exuding different sugars and compounds and things like that into the soil to feed that soil food web. So, and that is a really important soil building process. So all of these soil health principles are to maximize that process. Next. So let's just dive right in since I only have 20 minutes. What do we mean by minimize disturbance? So this is minimizing both physical and chemical disturbance to the soil ecosystem. So physical disturbance, is tillage and things like that. Chemical disturbance can be, application of pesticides or even fertilizer. So it doesn't say eliminate those disturbances completely. We just recommend you minimize them and use them very carefully and judiciously. So for a livestock situation, next, that can include things that you wouldn't normally tie to soils necessarily. One example I like to use is on our farm, we previously used a dewormer on the cattle, and it would pass through in their manure, and it would be spread around the pastures as they graze, and affected the dung beetle populations. And so we started testing to see if they needed that dewormer in the first place instead of just doing it every 6 months. And it turns out they didn't. And once we eliminated that chemical disturbance to the soil, we saw dung beetles come back, which then had the compounding effect of increasing our nutrient cycling, because those manure pies broke down much more quickly with the dung beetles there. So that was a positive way that our soils were impacted by removing a chemical disturbance we didn't need. Another example is instead of applying chemical nitrogen, figuring out, which legumes you can establish in your pasture, because those fix nitrogen biologically and can add it to your soil that way. And that's a much more slow process that doesn't throw the soil ecosystem out of whack. So those are some examples of what we mean by minimized disturbance in a pasture system. And there's many other ways that you can go about following that soil health principle on your farm. Next. So the next principle is maximize biodiversity. And that just means have as much and as many different kinds of living things on your farm as you can. Different types of plants, different types of insects, wildlife, things like that. If you can, have different types of livestock. But in a pasture system, when you're talking about plants, if you have biodiversity above ground, you're going to have biodiversity below ground, because different plants support different types of microbes and things under the soil. And that just leads to a much more resilient system in the soil and in your pasture, because you'll have microorganisms that can function and cycle nutrients, whether it's really hot or really cold or really wet or really dry. If you have that diversity, you'll have productivity throughout different weather extremes. So having diversity is really key. And it also is beneficial to your livestock's health. So if they're eating one thing all the time, it's going to do the same thing to them as it would to us. If we ate, just the same thing every day, it would get not only very boring, but our health would suffer. So having diversity is good for soil, livestock, and everything. Next. Another key principle is to keep the soil covered. And in a pasture system, people typically think that their soil is covered all the time if there's plants there. Unlike in crop system where it's tilled and it's clearly bare dirt. But you can see the difference in these two pictures. The one with the goats grazing, the grass is taller than they are. And you can't see the soil in the picture, but you can infer that it is well covered by that tall grass. Whereas in the picture with the poor skinny cow grazing in that overgrazed field, you can see patches of bare dirt. So that's an example of a pasture that is not covered. And the importance of keeping it covered is that it keeps that soil protected from wind erosion, from water erosion, and from temperature extremes. Because when it's exposed to the sun, in the heat of the summer here in Arkansas, that's a real challenge. And that soil can get over 100, 110 degrees. And those microbes in that soil food web just shut down. So there's no nutrient cycling and no biological activity when it is that hot. And so if you keep it protected, you'll keep it protected from those temperature extremes as well. Next. So living roots, keeping the plants actively growing as much of the year as possible. You want to, get it growing as early in the spring as you can, and then throughout the heat of the summer, and then as late into the fall as you can. Because the more time you have plants actively growing, the more of those root exudates will be essentially pumped into the soil and feeding that soil, the soil food web. So you'll be enriching your soil longer if you can get things growing on the shoulders of the seasons. These are just pictures of our pastures on our farm at different times of the year. And, we have a lot of Bermuda grass. So that's a, warm season grass. But even in that fall looking picture where it looks mostly brown, there's still a little green there. We're always trying to have at least a little green happening. And then throughout the summer and fall as well. Next. So include animals. Not everyone includes this as a soil health principle because they, not every farm can include animals or wants to include animals. But as this is a livestock workshop, I think we can safely include this one. And animals are considered a really important piece of this soil building puzzle because they really can increase the rate of nutrient cycling. They can stimulate plant growth. They can help maintain diversity in a pasture if you are grazing carefully, and they can provide income for farmers or people who can only afford marginal land. For us, our farm is on a hilltop, and it should never be tilled to produce any annual crops because all of our soil would be gone in just a matter of years. So it provides us a way to make money off of this marginal land that should be never be tilled. So that's beneficial for it's the best use of that land is including animals. But I'm not going to talk too much about this because I know Justin and Lee are going to explore this more. But it really is a critical piece of the soil health puzzle. Next. So those are the 5 soil health principles. But I really like to emphasize that there is no one right way to implement those principles. You have to figure out which practices you're going to use that follow the principles, but everybody's farm is going to be different. One key thing, though, is that you do have to follow all of them in order for it to really have a positive soil building effect. But however you do it on your farm is going to be different. Whether you have pigs, you can build soil health, cows, chickens, sheep, goats, bees, whatever it is. There's ways you can adapt those principles to your particular situation so that you build soil health on your land and within your the time that you have to do it. So there's no one right way, but it's a really good guidepost to follow is the soil health principles. And I also think it's really important that you don't sort of set it and forget it. You are constantly monitoring what you're doing to make sure that your soil is improving and to make sure that the management decisions you're making are in fact improving things, and make adjustments as needed. We've been grazing our cattle for I don't know how many years, decades, and we're finally realizing we are still overgrazing. So we've destocked this fall just because we're adjusting and looking at the pastures and adjusting more. So it's a constant and really fun process of observing and taking good notes and remembering what you did and adjusting as you go forward. And with soil health, as soon as you start making changes to your management practices to build soil health, it'll start adding up. So you'll start to improve your soil a little bit more, and that enables you to improve it a little bit more. And so all those successes will build on each other, and soon it'll be easier to maintain and improve your soil, especially if you're starting with some depleted soil. But it's a compounding process that is really exciting once you get on that road. Next. So one overall message I hope you will take away from this is that you have the power to regenerate soil health. If you're starting with degraded soil, which just most of you probably are, because that's our management hasn't been soil focused for the past 100 years or so, on generally speaking. I'm generalizing, but you have the power to regenerate your soil's health, to rebuild that soil health. But in order to do so, you have to give more to your soil than you are taking away. So we cannot keep taking more than we give. It's really important that we have that relationship to the soil is one of giving back. And that's how you'll ensure long-term productivity and health. And I think it's important in our farming systems that success includes building soil health year after year. It can't just be short-term profits, and it can't just be, you know, raising a prize-winning heifer. It has to also include building that soil health so that your farm is successful in the long run. Next. And this is still a relatively new area of study and understanding. And so everybody, I think, is learning the best ways to give back to the soil through our agricultural practices, the best way to graze, the best way to raise, you know, poultry on pasture, the best way to raise sheep. So I think there's so much to learn, and we all need to sort of be our own scientists as we do this. But it's kind of a big, exciting experiment, and one that'll keep you engaged as you work on your farm over time. Next. Another thing I want to leave you with is to try and find your reason why. So this is a picture of the creek that runs downhill of our farm, and that's my son from a few years ago. He looks very small to me now. But everything we do on our farm, good or bad, will end up affecting this creek, which is a really important part of our life. We spend a lot of time on this creek, and so I think this picture encapsulates my reason why I spend so much time and effort making sure we're doing our farming the right way. You know, I want things to be healthy environmentally, and I want things to be beneficial for my children, and I want the land to be better for them than it was for us. So I just want to keep things improving. So farming is not always sunshine and daisies, and I think it's good to have this kind of image, whatever your reason why is, in your back pocket for those hard days, to keep you motivated and to keep you on track. So I just like to leave you with that final thought. Next, I think it's my last slide is next. Oh no, that was my last slide. Okay, so if anybody has any questions, I'm happy I'll throw my email address in the chat, and you can follow up with me after, at the end, or sometime after, and I'm happy to answer your questions. Thank you so much.
Thank you, Nina. Nina's email is coming out to you tomorrow in an email with the resource list too. Thank you, Nina, for setting the stage for us. Our next speaker is Justin Morris, and Justin has some internet issues. I wonder if some of you can relate. So the way we're working around that is Justin has recorded his presentation. He is here. He's able to answer questions. He's working in the chat, but his presentation is going to run as a video for 20 minutes. And he's going over some really crucial principles that will help us respect the soil health rules. So thank you. We have one poll, I believe, and then we'll move into Justin's presentation.
Hello, everyone. My name is Justin Morris, and I'm a regenerative grazing specialist with the National Center for Appropriate Technology. For the next 20 minutes, I'm going to discuss some of the basic foundations for getting started with grazing. In this presentation, we're going to answer some key questions. These include, how does grazing affect the plant, soils, and livestock at different plant growth phases? When should livestock arrive? How long should livestock stay? And when should livestock return? Our work begins with the miracle of photosynthesis. Here we see that sunlight, carbon dioxide from the air, and water in the soil are used to create glucose, which is a very simple sugar. Glucose is the most basic molecule of chemical energy, which is then converted into hundreds of different compounds. Good grazing management strives to nurture ecosystem processes so that the health of animals, plants, and soil are improved for long-term resilience. Additionally, grazing management needs to meet the needs of the grazier from a profitability and quality of life perspective. Grazing management controls four things: when livestock show up, how long livestock stay in the same location, how often livestock come back to the same location, and how close livestock are to each other. These four dimensions of timing, duration, frequency, and intensity change throughout the year because we're working with a living system that is constantly changing throughout the year. This is what makes grazing management just as much of an art as it is a science. Leaves are the solar panel for plants and is where sugars and proteins are produced. Here are some facts about leaves that every grazier needs to know. They include: young leaves are on the top, old leaves are on the bottom. Compared to old leaves, young leaves are more photosynthetically active, higher in sugars and proteins, lower in fiber, more nutritious, and less infested with parasites. Finally, and this is a very important point, it takes leaves to grow new leaves. In this photo, we see a great example of how grazing management impacts not only the above ground growth of plants, but even more importantly, root development. Grazing management that utilizes some system of rotation where livestock move through a sequence of fields at the pace of plant growth allows plants to achieve a much greater above ground and below ground growth compared to plants of the same species where livestock have continual access to the same plants at any time. Continuous grazing leads to what is called overgrazing. While we all know that roots are essential for acquiring nutrients and water, consider for a moment how these plants would handle a drought. How would a plant fare if it has a root system going down 2 or 3 inches like the tall fescue that's continuously grazed? As soon as the rain or irrigation shuts off, those plants stop growing immediately and will become dormant. This contrasts sharply with the plants pictured here, with much deeper root systems that can continue to be green and growing even after the rain or irrigation shuts off. I inserted the numbers in black with arrows pointing to those same numbers on the yardstick and tape measure so you can see the depth of the plant roots. This is data from probably one of the most frequently cited grazing studies in history. This shows that root growth begins to be affected by a single grazing event when 50% or more of the above ground biomass has been removed. And when 80% or more of the above ground biomass has been removed, 100% of the roots stop growing for at least 12 days. But what's the effect on plant roots when a plant is grazed 3 times a week, like what would happen in a continuously grazed pasture where livestock remain in the same spot for months? In the same study, it was also noted that root growth wasn't affected even in repeated clipping tests when 40% or less of the foliage was removed. This means that the balance point between foliage removal and stopping root growth was found somewhere between a 40 and 50% top reduction. So the key takeaway from the study shows that root growth is negatively affected by the severity of grazing and the time in which successive grazings happen. We saw from the previous slide that a single severe grazing at 80 or 90% is not ideal for multiple reasons. But given sufficient time for the plant to completely recover, root growth in the long run is held up for 12 to 17 days. Now compare that to what we see here when livestock keep returning to regraze the same plants 3 times a week and the plant is kept short at 60 to 90% of the foliage removed. root growth is shut down for at least a full month. And when most of the top growth has been removed over a long period of time, there isn't enough energy being captured to maintain an extensive root system. The plant then decreases root mass to maintain a balance between above ground foliage and below ground roots. This is why plant roots become shorter over time under continuous grazing, where plants are both severely and frequently grazed. When discussing grazing basics, the term severe grazing is often thought to be the same as overgrazing. Severe grazing is simply grazing a plant down very close to the soil surface. This can happen any time of the year, whether that's during the growing season or the dormant season. Also, a one-time severe grazing is not considered to be overgrazing unless the severe grazing keeps happening frequently enough so that the plant can't get fully recovered. Overgrazing, on the other hand, is grazing a plant before it has fully recovered. This happens generally through one of three ways: livestock staying too long while plants are growing fast, livestock returning too soon while plants are growing slow, and livestock grazing plants too soon after winter dormancy, severe drought, fire, or other major disturbance. Overgrazing usually results from the combined effect of severe grazing and animals regrazing the same plants too frequently. This condition happens only during the growing season, not the dormant season. The number one mistake in grazing management is grazing plants before they're recovered. Plants have three growth phases. Phase 1 is the vegetative phase, which goes from germination all the way to the development of several leaves, but no stem is formed. The plant is very low to the ground since no stem is developed and is very low yielding. Pastures in this phase look a lot like a lawn, very green but very short. In the graph on the right, pasture quality and yield are plotted according to each of the plant growth phases. The vertical axis represents pasture yield in pounds per acre of air-dry forage, and pasture quality is measured by the amount of carbohydrates and proteins in the above-ground parts of the plant. The horizontal axis represents the time of year from spring through fall. The green line shows that pasture yield during phase 1 is very low, and plant growth rate is also very slow, as indicated by the shallowness of the green curve. The yellow dashed line representing pasture quality follows an opposite trend by being very high in phase 1. So what happens when livestock are grazing purely vegetative pastures? From a plant perspective, this can increase the plant recovery time, decrease overall pasture yield, decrease root mass, and also root exudates. Root exudates are those compounds, the sugars and amino acids being given off by the roots into the surrounding soil ecosystem. It also has an effect on the soil in that it decreases cover, it increases compaction, and reduces the rate of soil aggregation. And from a livestock perspective, because the plants lack sufficient fiber, this can actually translate to a decrease in animal health and performance. Phase 2 is the elongation or transitional phase, because a stem is being formed and the plant is growing taller. In the graph on the right for phase 2, the green curve representing pasture yield continues to increase and gets very steep, showing that the plant growth rate is fast. On the other hand, the yellow dash curve representing pasture quality is declining through this phase at the same time. But while pasture quality is declining from a carbohydrate and protein standpoint, fiber, which is essential for proper rumination, is higher at this point, making the diet quality overall better for livestock. The intersection of the green and yellow dash curves in phase 2 represents the optimal balance of yield and quality for livestock. This is one of the reasons why phase 2 is the best phase to graze plants. Another reason why phase 2 is the optimal stage for grazing is because this phase represents the time when plants are growing the fastest, as shown by the steepness of the green curve. This means that the time for plants to recover when grazed and livestock are removed while plants are still in this growth phase will be the shortest. So what can happen when livestock are grazing plants in the elongation phase? Well, from a plant standpoint, this can actually decrease plant recovery time because plants are growing quickly at this point in time. It can also increase pasture yield, as well as increase the root mass and, most importantly, the actual root exudates coming from the plant roots. From the soil perspective, it can increase the amount of cover, it can decrease compaction, and increase the rate of soil aggregation. And from a livestock perspective, this provides the most balanced diet for animals as they are getting sufficient fiber for rumination, which translates into an improvement in animal health and performance. Phase 3 is the reproductive phase, which begins with the formation of a seed head in the top of the plant and continues until the seed ripens. As we see on the right, in phase 3, the pasture yield curve peaks out and begins to decline, showing a gradual loss in pasture yield. At the same time, pasture quality continues to decline because the plant has developed a lot of stem to support a seed head. The stem is constructed of a complex carbohydrate called cellulose, which is indigestible to livestock. While the cellulose content is high, during this time, animal performance can still be pretty good, provided they don't spend very long in one location. This is the phase where some graziers group livestock very close together to get them to trample a lot of the stem material to the ground for better soil cover. What can happen when livestock are grazing plants primarily in the reproductive phase? From a plant perspective, this can increase plant recovery time, can decrease pasture yield, increase root mass, and decrease root exudates. From a soil perspective, this can increase soil cover, reduce compaction, but it can also decrease the rate of soil aggregation since the amount of root exudates is also starting to decrease. From a livestock perspective, the forages are much higher in fiber, which, if animals are kept in one area for too long, can actually cause a decrease in animal performance. From a plant perspective, livestock can arrive any time of the year if plants are recovered from either the prior grazing, winter dormancy, or other major disturbance. So, in essence, we're talking about ensuring that grazing doesn't happen until plants are in late phase 2 growth stage or later. From a livestock perspective, grazing plants that are at least at the late phase 2 growth stage is best for them because it provides plenty of carbohydrates and protein for good rates of gain, along with sufficient fiber for proper rumination. If livestock arrive in a pasture when most of the plants are at the top of phase 2, livestock can remain in the pastures until they graze the plants no lower than the bottom of phase 2 or until plant regrowth begins. How long of a time is that? Well, that's dependent on several different factors. In environments where annual precipitation is greater than 30 inches or where irrigation is available and plants are growing rapidly, such as during the late spring, a grazing duration of 3 days or less generally prevents livestock from regrazing any newly formed growth, thereby preventing overgrazing. When growing conditions aren't as optimal, such as during the heat of summer, and plant growth is slower, a grazing duration of 5 days or less is generally optimal to prevent overgrazing. As far as livestock returning to regraze the same field, removing livestock from the field by the time it's grazed down to the bottom of phase 2 ensures that the recovery period will be as fast as possible, as shown by the steepness of the green curve during phase 2 growth. It's important to note that plant recovery varies throughout the growing season, as shown by the two different timescales at the bottom representing spring and summer growth. Plants grow faster in late spring than they do in mid to late summer, when it can be a lot hotter and soil moisture is less. In the example above, the recovery period for beginning the grazing at the top of phase 2 and leaving by the bottom of phase 2 during the summer would take around 25 days. The timescales for spring and summer growth are just examples here. Your environment may be different. But if livestock are kept in the pasture longer so that it's grazed more severely down into phase 1 in the summer, then if the grazing duration in one area lasted for more than 5 days, newly formed plant growth is getting grazed again, which by definition is overgrazing. Additionally, it will take around 44 days for plants to grow back to the pre-grazed height in the summer. That's an additional 19 days of recovery time. The difference in grazing time between removing the animals once they reach the bottom of phase 2 and keeping them there until they reach the bottom of phase 1 could be only a day or less, depending on the situation. So when can livestock return to the same field? The answer is only when plants are recovered. But how do we know when plants are recovered? Here are some things to look for. Plants have regrown to at least the top of the elongation growth phase or later. No evidence of previous grazing such as chewed leaf tips. Plants are as dark green as possible, since plants generally get darker green as they regrow. It may be helpful to compare the greenness of plants in the pasture with plants of the same species that never get grazed to see this difference. And finally, the oldest leaves attached at the bottom of the plant are turning brown. Before I wrap up here, I want to show 3 different pasture layouts. The layout on the left represents the standard practice of continuous grazing where livestock have unrestricted access to plants anywhere in the pasture. This results in overgrazing, which decreases the health of plants, soils, and even animals. The only advantage this layout offers is that it takes no management at all. Just put the animals out there and let them do their thing. If you decide to split the pasture into 4 fields, as you can see in the center figure, so that livestock are restricted to just one of the 4 fields, then you get the benefit of having 3 fields in recovery mode. If this is summertime and we know that plant growth is slow, we need to ensure that the grazing duration in any one field does not exceed 5 days. We also need to allow for a 50-day recovery period because many of the most palatable plants will get severely grazed down to phase 1. So the question is, are 4 fields enough to prevent livestock from staying in one field too long, yet provide enough time for plant recovery? To get a 50-day recovery period, the graze period would have to be 17 days in each field. 17 days exceeds our 5-day maximum grazing duration in one field by 12 days. So while we stop overgrazing from occurring by allowing a 50-day recovery period, we still get overgrazing from staying too long in any one field. And if we decided to have livestock graze 5 days in each field, then it would take only 15 days to come back to where we started, which isn't anything close to the 50-day recovery period that's needed. But what about splitting each of those 4 fields 3 ways with some portable electric fence so we have 12 smaller fields as shown in the figure at the right? If we again use a 5-day maximum grazing duration in one of these smaller fields because it's summer and growth is slow, then it will take a total of 60 days for livestock to rotate through all the fields. Since livestock will be in only one of those 12 fields at any moment in time, livestock won't return to the same area for 55 days. That works. This prevents overgrazing from happening. The only downside to this layout is that it takes monitoring to make sure that livestock are moved through the 12 smaller fields at the rate in which plants are regrowing. So here are some grazing guidelines based on what we've discussed so far. Turn livestock in once plants reach phase 2. Stop grazing at the bottom of phase 2 or earlier when there are sufficient leaves remaining. Create at least 12 paddocks per herd to allow no more than a 3-day graze period during fast plant growth and a 5-day graze period during slow plant growth. Monitor pasture growth rates to adjust how fast or slow livestock are moving through the rotation. Don't bring animals back until the pasture has fully recovered. If no pasture is fully recovered before the second graze, move livestock to one area and feed hay until plant recovery takes place. And finally, fluctuate grazing timing, duration, frequency, and intensity to improve soil, plant, and animal health. Thank you so much for taking the time to watch this presentation. Feel free to reach out to me with any questions you might have. I'll now turn the time over to my colleague Lee Reinhardt for the third phase of this webinar.
Great, Justin. Thank you. I know you're here with us, and if anybody has questions for Justin, certainly type those in, and he can respond as we move forward. But there's a lot of information there, and we're certainly willing to have conversations with folks and kind of pick through some of those details and find out what works on your individual place. Again, thanks everybody for being here. I'm going to finish up the last section. We're going to have a kind of a shorter section here and talk about some basic principles, why our management matters. You know, what is it about what we do that affects the land that's of concern, right? And that how does that management that we do impact the land and our livestock? Mostly it's about observation. It's about implementation after we've observed and then adapting based upon what we've seen happen on the land, and then observe some more. So it's just a constant cycle. There's no silver bullet. And I think we all pretty much know that by now. There's no silver bullet to proper grazing management. Instead, using observation to calibrate your eye for what works well on your land and with your livestock. Really kind of paying attention to what happens while your livestock are grazing is a very intentional act. And it'll reveal to you that grazing is every bit as much of an art as it is a science. Let's go to the next slide, please. Okay, so I want you to just kind of take a look at this field. This is a picture that I took in Mississippi a couple of years ago. And just kind of keep that field in your mind a little bit as we go through some of these slides. We're going to cover some of the principles to define how the land responds to what we do. And then the decisions that we make based on these principles can help us achieve our goals of livestock productivity and pasture resilience. So look at that photo. Notice what's out there, okay? Looks like a lot of goldenrod and weeds and stuff, and it may not have been used in a while. It may have been an old crop field at one point. But we're going to return to this field a little bit later in our talk. Next slide, please. Okay, so we're going to talk about a couple of three principles here that have been developed by Alan Williams. And some of you may know about Alan. He is a sixth-generation family farmer, and he's the founding partner of Grass-Fed Insights, LLC, and Understanding Ag and the Soil Health Academy. Does a lot of speaking. He's a really knowledgeable grazing consultant. And these principles basically come from Alan. And he's done some work with us and some field days and such. And we have some videos on our site that we're going to be sending you some references and stuff, so you can kind of look up and have him go into a little bit more detail on this and some of the principles that Justin was talking about as well. But basically, he talks about the principles of compounding, diversity, and disruption, all within the confines of flexible management. Flexible management within your grazing system is goal-oriented. Alan says it focuses on stock density and not stocking rate. It's necessarily flexible. A lot of adaptation, a lot of observation of what's going on. Using rotations, looking at your grazing residue heights and your rest periods and the grazing seasonality throughout the year will probably never be the same in an adaptive system, because you're basically grazing your paddocks based upon what your goals are and what you'd like to get out of the land. Adaptive grazing uses frequent movement and adequate pasture rest for full plant recovery, and is highly reliant on temporary fencing. Some of those principles that like I said, that Williams discusses are in some videos that we have that we're going to be sending you in our resources tomorrow. So next slide, please. Okay, so our first management principle, the principle of compounding. We know that the effects and the impacts of changes on our landscape that happen, whether it's from something that we do or with this weather or climate or whatever, are never singular, but they're multiple, and they intensify the changes that happen again as time passes. Everything that we do on the landscape creates a series of compounding and cascading effects and cascading events, which are never neutral from the producer's perspective. They're always either a positive or a negative event, result, basically. And so as producers, you know, we realize that changes happen, and it can be positive or negative. And so we look and we adapt, and we put our land on the livestock in a particular way for a particular purpose and observe what happens. And if it's a positive effect, we investigate that. What happened? Why is the grass responding that way, right? For example, a paddock that is grazed for a short period of time with high animal density, let's say 100,000 pounds of live weight per acre equivalent, and allowed to rest to full recovery, over time will experience a plant community change in both density and diversity. And so keep that in mind because we're going to talk a little bit more later about this and why that's important for grazers. Let's go to the next slide. Okay, so the next principle is the principle of diversity. Our other presenters, Justin and Nina, have been talking a lot about diversity, and it's really important with respect to our management, because the diversity, highly diverse pastures are very complex, and they create positive compounding of effects. All right, the goal is to have highly diverse and complex pastures. Think about having grasses, legumes, forbs all together, summer and winter species together, annuals and perennials together. Notice that picture there on the left. You've got various types of grasses and forbs occupying different levels within the above ground and the below ground soil profile, taking up all those niches, taking nutrients from deep into the soil, from shallow, and really giving a lot of diversity to the pasture. That's really important from a livestock nutrition perspective, as well as an ecological perspective for the soil health. Diversity provides really kind of a complete nutrition for animals. You might have heard about Fred Provenz's talks about animals having nutritional wisdom. There's so many primary, secondary, and tertiary nutrients in all these various plants, and animals are able to select for what they need after they satiate on a particular plant. It reminds me of a story where we were doing some work in Southwest Montana with Montana State University, grazing sheep on leafy spurge, which is a pretty noxious perennial weed in the Western United States. And we were doing transects and exclosures and doing plant counts, and we were noticing that after the sheep were initially turned on to a field full of leafy spurge, they would satiate after a while, and they would stop eating the leafy spurge and then start eating the grass. And then whenever the grass got to a point, we would move them, and then they would come back again, usually twice per year per season, to hit that leafy spurge again. And we were able to seriously reduce the spurge on those rangeland pastures. But what we also learned is that we saw that the animals, whenever they have a lot of diversity, they're going to eat what they need, and then whenever they get enough, they're going to go eat something else. That's another good reason to have a lot of diversity out there. Nature tends toward the stability that comes with species complexity. Remember that complex systems occupy all the available plant space above and below the ground and utilize nutrients and water more effectively. And nature really wants to fill all those niches. When we leave a gap, right, due to either overgrazing or poor germination of plants or some other disturbance that leaves the soil bare, nature is going to want to fill that gap with opportunistic and adaptable plants, which we often call weeds, right? But in fact, forbs and grasses, we typically call weeds, are nature's bandage that helps the landscape recover from disturbance. So whenever we're going to do some type of disturbance, which we're going to talk about next, we want to do a planned disturbance with adequate residual and full recovery after rest, so we can send that plant community succession in the right direction toward diversity and really kind of increase our productivity. So let's go to the next slide, please. Okay, so here we're talking about our last principle, the principle of disruption. Planned purposeful disruptions build resilient systems with more vigor and diversity and create positive compounding effects. All of these things, if we put them into place, can really give us those positive compounding effects that affect, you know, all the systems within our pastures. Nature's very resilient and it responds very well to changes. So we mimic these with planned purposeful disruptions to create a host of these effects. For example, we know that grazing improves tillering, especially in the early season. Now, tillering is whenever plants will start initiating leaf growth after they have been grazed, or they start shooting out side shoots from the bottom of their of the grass plant, usually because of a defoliation event, right? And tillering really tends to increase the density of a pasture sward. The more stems you have, the more leaves you have, the denser your pastures are. But we have to take care to leave enough residual during this period for adequate growth. So if we want to provide some type of disruption, we can graze it. We can graze plants in the spring, but not too heavily. Allow that growth to start tillering and get a more dense stand. Just one way of doing a very light type of disruption. Another, we can reclaim overgrown weedy fields with purposeful disruption, or maybe we want to severely graze a field in order to allow the germination of overseeded winter annuals or something like that, so we can get those seeds down into the soil surface. There's lots of different ways that we can use planned purposeful disruption to send succession the way we want and to create positive compounding effects. Again, full recovery of our plants after a disruption is really important, because any grazing event is a disruption, and they need to be fully recovered before we put the cattle on them again. We're going to go into a lot more detail into this in our next class. You probably will be seeing in the next couple of months that we'll be putting on an advanced class in grazing, and where we will use some of our poll questions and such like that in order to come up with some really good content, to have a really good discussion on these concepts, bringing them in deeper and having some more question and answer. All right, let's go to our next slide. Okay, so I told you to remember this photo. This field is ready for disruption, right? But disruption that is timed and purposely implemented. If we were to take livestock and put them across there at a high density for a short period of time, allowing an awful lot of recovery time for those plants, we can change the character of that field, and we can do, depending upon where you are. In the Southeast, it could be a couple of years. In the semi-arid West, it would be even longer than that. But we can definitely make some changes to the land by having that grazing impact from the animals. Let's go to the next slide. So this is kind of like what we could turn that pasture into, right? This isn't a before and after picture of the same field, but you get the idea. Over time, applying the principles of adaptive regenerative grazing can produce site-specific resilient pasture ecosystems from grazing impact alone, without adding seeds, without adding fertilizer, using the animals and the biology of those animals, the urine, the manure, the trampling in of the of the residual grass from hoof action, feeding the soil microorganisms and keeping that system going. Remember, purposeful grazing and full plant recovery is what we're talking about here. So that's it, and that's all I got to talk about. But again, you know, I haven't been looking at the chat. If you guys have any questions, certainly we can answer some. My email address and phone number will be out as well. And I like Nina and Justin, welcome having a conversation on how some of these principles might fit within your system. It was a pleasure to discuss these things with you. Do reach out if you need. And next, Linda Coffey is going to discuss some resources to help you in decision making and kind of summarize our discussion for today. So thanks.
Lee, thank you. And I'm looking forward to your advanced grazing class, and we can turn you loose with teaching what you know. Thank you so much for the class tonight. Nina, Justin, Lee, thank you so much for teaching. Everyone, thank you for being here. We have just a couple more things to do. These resources are coming out to you in an email tomorrow. Lee has put together a resource list that I know you can click right into and get right to these. So one thing that I do want to mention, the adaptive grazing you can do it part is the videos that Lee was mentioning, and the regenerative grazing web pages will take you to a host of resources. You're going to get all of this tomorrow. Okay, next is the survey, right? We're going to do a short survey and then turn you loose with questions and answers. These are the take-home messages from tonight. Tonight was the foundational talk about what we need to understand so that we can do a good job managing our land. So we learned about the soil health principles. We'll talk a little bit more about soil next week. Grazing plants at the right time and always allowing full recovery. Justin and Lee both said this over and over, and because it's so important. Observe and adapt and pay attention. And we're going to go into this a lot more next week with Linda Poole and Justin Morris and Lee Reinhardt are going to teach about regenerative grazing, soil health, water infiltration, land carrying capacity, and just give us some more about looking, you know, using our eyes, training our eyes. I'm looking forward to that. I hope you will all join us next week. And let's do the survey and then questions. We'll open it up to questions and answers. Thank you all for being here. Thank you for the NCAT team being here in force. I really appreciate it. Thank you. I think we're ready to handle questions. And it doesn't have to be me. What's in the chat, or would people like to unmute?
Linda, I've got a question.
Go ahead, Dennis.
How many years to move from being a novice to at least intermediate as a grazer? How many years of skill would it take practicing grazing to move from a novice to being intermediate?
I'll give one answer and I'll let everyone else answer. I think it depends how observant you are and how much you do learn from what you see and your actions. But different conditions every year, you won't have it mastered in the first year, I'm sure. Team, what do you all say?
So I agree with that, and I think that it's kind of subjective too, right? Because you really can't, or I wouldn't advise, putting yourself, up against and comparing you to other grazers because they're not grazing your farm. You're going to get to know your farm. You're going to get to know what works there. It's so different, but everybody has different observational skills, different levels of what they can stand and what they and what they can bear and what they think is successful. Think about this. A lot of the fields that we're seeing in adaptive grazing now don't look anything like what we were told they should look like when I was in college. When I was in college, it was, you wanted a monoculture field of Bermuda grass in the south or orchard grass, in the north or something like that. And that was what was nice. Everybody wanted to drive by and see a monoculture, beautiful green field, all at the same uniform height and everything. But we know now that that's not good either ecologically, or really for the animals from a nutritional standpoint. So so we see fields that are a lot more diverse now, what other people would have back in the day called ugly, right? Well, you got weeds in there. It's like, well, guess what? Cows eat those too, you know, give them a chance. So I think that that because, you know, graduating from a beginner to an intermediate is just based upon what your expectations are. And like Linda said, how will you observe and adapt on your own property? Remember, you're not competing with anybody else but yourself.
Yeah, good answer. I saw somebody in the chat mention that stock water is one of their problems with grazing. You know, we had the questions about what are your hindrances? Is it fences? Is it land? Is it knowledge? Yeah, stock water is a big one, and it was a hindrance for us too. We found that, you know, looking back, if we had put more of a priority on how to get water in every pasture 25 years ago, that would have been great from a nutrient management standpoint. I do think that's a big problem. We've solved some of it by hauling water. We've solved some of it by working on how to pipe water and how to gather water. NRCS is a wonderful resource. And Justin, can you address what NRCS can do for people, please?
Yeah, so if you visit your local NRCS office, and there's usually an NRCS office in every county, they're usually located under USDA, but NRCS has they provide technical assistance, number one, where they can actually come out on your property and take a look at it, and they actually have the surveying equipment to be able to figure out distance to water, pipe diameter, stock water size according to the herd or flock that you're running. And then they also do offer a potential for cost share assistance. So sometimes stock watering facilities can cost, you know, by the time that you buy pipe and you put it in the ground and you're buying a stock tank and you're putting, you know, burying part of that into the ground, getting that secure. It may also involve drilling a well and having a nurse tank there. You know, that can oftentimes be very, very expensive. And through the EQIP program, which EQIP is EQIP, which stands for Environmental Quality Incentives Program, that is a program that allows producers to potentially gain access to federal funds to then be able to get part of their watering infrastructure cost shared. You would still be responsible for probably close to 50% of whatever the structure costs, but then that EQIP cost share would probably defray at least, you know, somewhere around 50% of the total cost. You may also be required to have a grazing plan in order to have that watering infrastructure available on your property. So there's definitely some things to take into consideration on that, but I would just go into your local NRCS office and visit with them and see what they can do for you.
Yeah, thank you, Justin. John Stites asks a question that I wonder if Linda Poole or Justin would handle. He says, as we learn to embrace diversity, certainly a change from what we grew up with, where can we find a handy grass plant identifier for the land we are grazing? We are Northwest Montana.
I'll go ahead and answer that one. And Linda's probably got some other good resources. I was just kind of thinking, you know, a good book to have on the shelf is Weeds of the West, because that has that will have a lot of plants that are that, you know, that'll pop up in Montana. So being able to identify, you know, some of those forb species that we are not liking necessarily. Weeds of the West is a great resource. There is also I think it's called Montana Plant Life. And that is actually something that you can either download or subscribe to. And it actually has some really good pictures of hundreds of plants that are native to Montana. And so those are two really good resources to check out that have stuff that'll show up there where you're at, John.
Yeah, thank you, Justin. Tracy answered a question and answered it really well about toxic plants. And I'd like to read Tracy's response because it's really important. We talk about weeds and some plants are toxic, but it's really important to recognize that, as Tracy said, it's hard to generalize. What's toxic to some species is not toxic to others. And if there's a lot of biodiversity, as Lee talked about, animals can handle small quantities of things that are sometimes considered poisonous, toxic. So sometimes if you look at a list of what's poisonous to your plants, you can kind of panic about that. But if we offer plenty of diversity and plenty of vegetation, we never force them to graze down too short, so they have choices, we will rarely lose an animal. That's in my experience in the East. It may be different for you in the West.
Well, and here's something else that we've learned about too with diversity is that, and Lee brought up Fred Provenza, emeritus professor at Utah State University, is that when you look at all plants, even take some of our tame grass species like orchard grass, we don't consider orchard grass to be, toxic necessarily, but one of the things that Fred brought to light is that, when animals get satiated on something, and Lee brought this up, when they get satiated on something and they get their fill on a particular plant species, that is a result of biofeedback that's going on inside the animal. So if you take an orchard grass plant, for example, and if you were to break it down into its various primary and secondary compounds, it has a signature or a fingerprint of certain compounds. But what happens is once those compounds get to be a high enough concentration in the rumen, it then triggers the animal to want to go away from that forage and not eat any more of it. So the animal will naturally want to seek out more diversity if the animal can get it. So when you look at plants, even just our tame plants that, are orchard grass, meadow brome, pick your plant. All plants, if the animals are forced to eat just that plant alone for a long enough time period, eventually it becomes toxic to them. So that's where, again, we have to have that diversity in our pasture ecosystem, because that's going to help balance out those biochemical compounds that are contained in those plants so that animals are getting a more well-rounded diet. And it's no different than for us, right? I mean, if we were relegated to eating, pancakes for a couple of weeks, probably after about the second or third day, we'd be like, I'm going to fast for a while because I just cannot handle eating another pancake for breakfast, lunch, and dinner. And so just as we crave diversity, the animals follow the same pattern.
Yeah, thank you, Justin.
Excellent points.
Participants, you are welcome to unmute and ask a question. We'll give you that opportunity, and we have a great team on to answer it. So you're invited. And if there are no more questions, then I will just say thank you all for being here tonight. I hope you will all come back next week. And in the third week, we are going to have a really good time talking about choosing livestock for your farm. Next week, one of the important things that Justin is going to address with us is how to decide how many livestock on your farm, because if you have too many livestock, you cannot allow enough time for the grass to recover. So this is a really important question for those of you who are starting and need to learn how to figure that out. Justin's going to be super helpful. I'm looking forward to next week and the week after that, and thank you for participating tonight. Are there more questions? Okay, you'll see resources tomorrow, and you'll get all of our emails tomorrow. And I encourage you to reach out to us. And thank you so much for being here. Thank you, livestock team, and Nina. Thank you.
Thanks for having me.
It's great to hang with you guys. You bet.
Thanks, guys.
Thank you.
So many more questions are coming in. If you do not have enough cattle on your land, should you shred? That's that one is a big one. It's the same thing with like aeration. You've got your no shredders, and you've got people that say you should shred. Cattle always work best on that. What does mowing do, right? Well, it sends the grass and the forages back into succession, right? Into the lower phase, back to the phase, beginning of phase 2, basically, right? But what you're not getting is you're not getting the biology, right? So it's a trade-off, right? I have always said that you know, it really depends upon what your goals are. You know, I'm not a person who says you should never mow, or that, you know, mowers aren't useful, because they have benefits in weed management sometimes, whatever. So anybody else have anything on mowing?
Yeah, I was just going to say, Lee, along with that, if there are not enough cattle on the land necessarily, that could be a tremendous opportunity to pick up maybe either some animals from somebody else that you could, you know, custom graze for 2 or 3 months to eat down some of that excess that's there, depending on how much excess we're talking about. If we can get the forage to go through the gut of an animal, that's always going to be better than a mechanical solution, because like Lee was saying, you know, the mower isn't going to be adding biology necessarily to that land. You know, it's just going to be clipping that plant at a set height and throwing it right back down. Ideally, what we really want is we want that forage to go through an animal as much as we can. So I would say to Tina here, or anyone else, look for, you know, if you've got other graziers around you, they're always looking for more land. So I think there's plenty of opportunities, given the right relationships, to be able to bring an additional group onto your property to be able to utilize some of that excess, and that could be an additional revenue source to your operation.
Yeah, great points, Justin. Thank you. All right, any more questions? We're not rushing anybody out the door.
I'll tell you what, this is an excellent way to spend an evening.
Yeah, it's nice to be gathered together with people who care about the same things, and share ideas and knowledge. Yeah, I agree. All right, well, it's 6:30. I said we are ending at 6:30, so I think we will, but please, Tina, yes, there's a lot to learn about grazing and soil management. We've been learning for years, and I'm very excited about how much we're still learning. NCAT did a soil health conference last year. Nina, could you unmute and talk about where they can find those videos?
Sure. Yeah, we had 2 days packed with speakers from all over the country about all different soil health topics. And we recorded all those sessions because it was a virtual conference this spring. And it's either on the ATTRA website, attra.ncat.org, as you can see on the screen, or you can go to YouTube and find the NCAT ATTRA YouTube channel, subscribe.
Yeah.
And
Margot just posted it. Yep.
Aha, thank you, Margot. Yeah.
Thank you, Margot.
And then there's a playlist of like 19, I think, videos of experts from all over the country and farmers talking about everything having to do with soil health. It was an awesome conference, and I can't wait to go back and watch the ones. There were concurrent sessions, so I missed some. So anyway, in your free time, check those out. Thank you for giving that a shout out, Linda.
Oh, absolutely. It was phenomenal. And the winter's coming when, maybe you have a little more time to watch videos and learn more. I'm looking forward to that grazing management class that Lee and Justin will do. And I'm looking forward to next week and the week after that. We're going to have in the third week, y'all, we're going to have farm tours from Nina's on a farm, but so are a lot of our NCAT people. And I'm looking forward to them giving you those real world examples of here's what we do. And we'd like to hear from you all too about what you do. So you can email us, and thank you for participating tonight.